Hello students, this is Varun. By now we are done with the topic of polynomials. And we know that polynomials can be classified on the basis of their degree. Polynomials with degree 1 are what we call linear polynomial, and if we talk about the general form of linear polynomial, then they are ax plus b. Polynomial with degree 2 is what we call quadratic polynomial, and they are expressed as ax square plus bx plus c. And polynomial with degree 3 is what we call cubic polynomial with the general form ax cube plus bx square plus cx plus d. In all these polynomials, x is the variable, whereas a, b, c and d, they are constants. And one thing that you need to mind is leading coefficient should never be 0. Leading coefficient in case of linear polynomial is a. Leading coefficient in case of quadratic polynomial is again a. Leading coefficient in case of cubic polynomial is again a. Leading coefficient of any polynomial can never be 0, because in case of this cubic polynomial, if leading coefficient, that is the coefficient of x cube, becomes 0, then it will no more be a cubic polynomial, but it will turn into a quadratic polynomial. In the same way, leading coefficient in case of quadratic polynomial is the coefficient of x square. And if the coefficient of x square, which is still a, if a becomes 0, then it will no more be a quadratic polynomial, but it will turn into a linear polynomial. In the same way, if leading coefficient, which is the coefficient of x of a linear polynomial, becomes 0, then it will just become a constant polynomial. So in a polynomial, leading coefficient can never be 0. And now let us recall the term degree as well. Degree of the polynomial refers to highest power of variable. In case of cubic polynomial, degree is 3, since the highest power of variable, which is x, is 3. Degree of this polynomial is 2 and degree of this polynomial is 1. In case of constant polynomial, degree is 0. In case of biquadratic, degree is 4. While doing polynomials, we did one term, that is zeros of polynomials. Zeros of polynomial. By the term zero of a polynomial, we actually mean that value of variable for which the value of whole polynomial becomes 0. For example, let's px is any polynomial, and for alpha, if p of alpha becomes 0, means if we replace x by alpha, and by doing that, if the value of polynomial becomes 0, then alpha is 0 of polynomial. Let us try to understand this with an example. If 3x plus 4 is a polynomial and we replace x by minus 4 upon 3, then we get 3 into minus 4 upon 3 plus 4, 3 and 3 get cancelled, we get minus 4 plus 4 equals to 0. Means when x is replaced by minus 4 upon 3, the value of this polynomial becomes 0. So we can say that minus 4 upon 3 is 0 of this polynomial. Now we will use this concept to develop another topic. If px is any polynomial, let px is quadratic polynomial. Px is quadratic polynomial, then p of x equals to 0 is what we call quadratic equation. If px is any quadratic polynomial, then p of x equals to 0 is quadratic equation. So let me explain this. We know that quadratic polynomial is of the form ax square plus bx plus c. Means if we put ax square plus bx plus c equals to 0, this is what we call quadratic equation. So now we will study about quadratic equations and their applications. So let us define the quadratic equation first. If Px is a quadratic polynomial, then Px equals to 0 is what we call quadratic equation, and the general form of quadratic equation is ax squared plus bx plus c equals to 0, where a, b and c are real numbers and leading coefficient is not equals to 0, means coefficient of x squared, which is a, should not be 0, because in case a becomes 0, then it will become a linear equation. Well students, next we have roots of equation. If Px is a polynomial, then zeros of polynomial will become roots of equation. Zeros of polynomial will become roots of equation. So let us see. By root of equation we actually mean if P of alpha equals to 0, that is if alpha is 0 of polynomial Px, then x equals to alpha is root of given equation. Since quadratic polynomial has at the most 2 zeros, so quadratic equation can have at the most 2 roots. In coming videos we will study more about the nature of roots and how are they used to solve the equation. Now we will see some examples of quadratic equations like 2x squared plus 3x plus 1 equals to 0. Yes, this is a quadratic equation because its degree is 2. 4x squared plus 3 equals to 0. Yes, this is also a quadratic equation since degree is 2. 19x squared equals to 0. Yes, this is also quadratic equation because degree is still 2. But if we talk about 14x cubed plus 7x squared plus 15x equals to 0, this is not quadratic equation because its degree is 3. For an equation to be quadratic, its degree should be 2 only. And here we are particularly talking about quadratic equations in one variable only. But students, quadratic equations are of significance because they enables us to solve various word problems after framing quadratic equations. So now we will see that how can we frame quadratic equations. We know in previous chapter we framed linear equations. Now we will frame quadratic equations, but we have to mind one thing, that we are dealing with quadratic equations in one variable, so we will try to take only one variable. But in case there is a problem of quadratic equation and you have taken 2 variables, then no problem at all, because that equation will ultimately turn into a quadratic equation only. So let us start with some examples. Here the problem is sum of 2 numbers is 27 and their product is 182, and we are interested to find the numbers. Well students, we can find the number. Well students, we will suppose that let one number is x. Since sum of 2 numbers is 27 and one of them is x, then obviously other will become 27 minus x. So other number equals to 27 minus x. Now back to the statement. So we write according to question. It is mentioned that their product is 182. We know that one of the number is x and other is 27 minus x, and the product of these two numbers is 182. So we must write x into 27 minus x equals to 182. On simplifying it, we get 27x minus x squared equals to 182. So by keeping all terms on left side, we get minus x squared plus 27x minus 182 equals to 0. And we will always try that leading coefficient should be positive. So accordingly, I am going to multiply the whole equation by minus 1. So the signs will get changed. It will become x square minus 27x plus 182 equals to 0. So this is the required equation. This is how we can frame the equations. Solving the equations we will discuss in next video. Now let us take one more example. The problem is altitude of a right angle triangle is 7 cm less than its base and the hypotenuse is 13 cm, and we are interested to find remaining two sides. While students, they are talking about a right angle triangle. We know that in a right angle triangle, three sides are there with one angle right angle. So it is mentioned that in right angle triangle, the length of hypotenuse is 13 cm, and they have mentioned that altitude is 7 cm less than the base. Actually, they have defined altitude with the reference of base. That altitude is 7 cm less than the base. If base is x, then altitude will become x minus 7, that is 7 cm less than the base. So let us start with base equals to x centimeter, then altitude will become 7 cm less than the base, that is x minus 7 centimeter, and it is mentioned that hypotenuse is 13 cm. And we know that in a right angle triangle, three of its sides are related to each other by the relation that hypotenuse square equals to sum of square of remaining two sides, which is Pythagoras theorem. So by using Pythagoras theorem in the given triangle, we get hypotenuse square equals to base square plus perpendicular square. Here the value of hypotenuse is 13 equals to value of base is x, and that of perpendicular is altitude, x minus 7 the whole square. On simplifying, we get 169 equals to x square plus, here I am going to apply the identity of a minus b the whole square, which will be a square minus 2ab plus b square. On simplifying, we get 169 equals to 2x square minus 14x plus 49, and when we shift 169 to right side, it will become 169 minus 49. Either it could be shifted to left side or right side, but I am trying to write in the simplified form. So let 169 be negative and 49 be positive. Minus 14x plus 2x square equals to 0. Continuing that, we get 2x square minus 14x minus 120 equals to 0. While students, we will always try to write quadratic equation in the simplest form. So if possible, then we will try to take the things common here. Since 2 can be taken common from all the coefficients, so I am going to take 2 common, and in the bracket we left with x square minus 7x minus 60 equals to 0, and when we shift to right side, that will become 0 upon 2, so we can neglect that. So the required equation will become x square minus 7x minus 60 equals to 0. This is our required equation. So this is how we can frame quadratic equations. In next section, we will discuss about finding solution of quadratic equations. Thank you.